Okay, so sorry about that. Let's continue from where we left off. So I just want to fill in the table of values with what you should have had from the other day, where you're guessing kind of how the pattern would continue. So if your length of base is 0, so if you have no side length here, then you can see 0 unhidden cubes, so this number right here is 0. Okay, if the length of base is 1, that was what this scenario looked like, then you can see 1 cube. So this next number is 1. If the length of the base was 2, so that's what this is, 1, 2, then you can see 1, 2, 3, 4 cubes. And then next we have the side length of 3, 1, 2, 3, and you can see here 1, 2, 3, 4, 5, 6, 7, 8, 9 cubes. So this would be, next would be 9. So to continue the pattern, you would have had to continue to build the rest of the blocks. So hopefully you did that and you filled out the rest of this. So I can tell you that the next number would be, maybe also you've seen the pattern, is you can see that the next value would be 16, and after this would be 25, and after this would be 36. Okay, so let's describe that pattern right now. So one thing at a time here. Let's close that. Okay, so so your table of values hopefully looks something like this. So let's break down our first differences. So first differences are the differences between the y values here. So if we treat this one here, this column as x and this column as y, then the differences between the y values, as long as the x values are evenly spaced, which they are, they're all going up by 1, would be 1 minus 0. So here our first differences would be 1 minus 0 is positive 1, because I'm going from 0 up to 1. From 1 to 4, that's a difference of positive 3. I'm growing up by 3. The difference between 4 and 9 is 5. That would be my next first difference. The difference between 16 and 9 is 7. And hopefully you can see a pattern forming. 1, 3, 5, 7. Can you guess what the next number is? It's 9. And then after that, it's 11. Okay, this is something that later on we're going to refer to as the step pattern. Okay, but for now I'll just tell you, all right, so 1, 3, 5, 7, 9, 11. Hopefully you can see the next pattern, next number in the pattern would be 13, then 15. These are all the odd values. Okay, so now if we're looking for our second differences, let's change to another color. So second differences are about taking the differences between the first differences. So from 1 to 3, that's a difference of 2. It's positive because we're going up from 1 to 3. And then from 3 to 5 is 2 again. I can do that by doing 5 minus 3. Next I do 7 minus 5 and I get 2. I do 9 minus 7 and I get 2. And then I get 11 minus 9, which is also 2. Okay. Oop, I don't know why I put a 3 there. That's a 2. Sorry. Okay, so all of our first differences were different, but our second differences were all 2. Okay, they were constant. They were all 2. All right. So then what you would have done next is plot all of your points. So if I make this horizontal axis go up by 1, so 1, 2, 3, 4, etc. And then I'm going to make my y values go up by 2. So this is going to be 2, 4, 6, 8. I'm going to have not quite enough room, but it'll be close enough, so I'll just go a little bit above. So I'm going to have these go up by 2s, and these ones go up by 1s. So I'll plot them now. So we have 0, 0 is our first point. If we have 0 side length, we have 0 blocks. 1 side length, 1 block. 1 and 1. That puts a point right here. Next is 2 with 4. Next is 3 with 9, which would be here. 4 with 16, so this is 10, 12, 14, 16. Next would be 5 with 25, so 16, 18, 20, 22, 24, 26, so halfway would be 25. And then 36, so this is 26, 28, 30, 32-ish, 34, 36-ish. Okay, so we know 36-ish would be about up here. So this is the graph that you drew the other day, and as you can see, it curves upwards. It is not linear. Okay, we have that sort of curve going. I know my line isn't very curved in the way it's supposed to be, but hopefully you can understand and sort of get the picture. Okay, so the next thing I want to talk to you about is, well, the fact that this is the most basic parabola. This is y equals x squared. Hopefully you see that that is the pattern. So let's back that up just to talk about that patterning. So you know how we discussed this 1, 3, 5, 7, 9, 11, that was the gap between the spaces of the nines. But if we look at the pattern a different way, instead of going from from y to y to y to y to y, instead let's look at the relationship from the x value to its y value, from x to y, from x to y, from x to y. Hopefully you can see the pattern that 0 times 0 is 0, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36. So in all of these, we're taking the x value and we're multiplying it by itself to get the y value. So that's where this equation comes from, this y equals x squared. That means that y is whatever x was, but squared. So when x was 4, y was 4 squared, which was 16. That's the most basic parabola. The key thing about this equation is this squared. Okay, that square is what makes the shape the way it is. And this is y. Okay, so I'm going to use that y equals x squared pattern, but I'm going to go the other way. So I know this doesn't make sense, but let's just pretend for a second that it would be possible for us to have an x value of -1. So as though we could have a negative length. I know that's not physically possible, but just bear with me for a second. So if we could have -1 as a length, then we could easily have -2 as a length, -3 as a length, -4 as a length, -5, and -6. Okay, so let's just pretend that these are possible x values for a second, okay? So if they were, and y equals x squared, then our y values would just be squares of these ones. So just like how we did 1 times 1 and got 1, or 2 times 2 and got 4, or 3 times 3 and got 9, let's do the same thing over here. So we have -1 times itself, which is -1 times -1, which would give us, oh look, +1. Okay. Then here we have -2 times itself, which is -2 times -2, which is, +4. -3 times itself is +9. -4 times itself is +16. -5 times itself is +25. And -6 times itself is +36. So if you notice, these are all the same numbers. It went 0, 1, 4, 9, 16. Now it says 0, 1, 4, 9, 16, but going in the other direction. And that's because anytime you square a number, whether it's positive or negative, the result is going to be positive. So it doesn't matter if you started with a positive or negative, because no matter what, when you square it, it will become positive. So now let's see if our first differences still continue. Well, the difference between 1 and 0 is 1, but from 1 to 0, I'm actually going down. So the difference here is -1. From 4 to 1, I would have to go down, so that would take me to -3. From 9 to 4, that would be down, so that would take me -5. From 16 to 9, that would be down -7. From 25 to 16, that would go down, so -9. And then from 36 to 25, that would go down by 11. Okay, and now second differences again. Okay, so the difference here, oh, did I miss one? No, I think we're good. Okay, the difference from -1 to 1, that space is 2. We would have to go up from -1 to 1 by 2. From -3 to -1, we'd have to go up by 2, so again positive. From -5 to -3, we'd have to go up by 2. -7 to -5, we'd have to go up by 2. -9 to -7, we'd have to go up by 2. And -11 to -9 would have to take us up by 2. So notice that even when we had weird negatives happening over here, our second differences were always the same. So that's a key feature of our quadratic equations or parabolas, is that the second differences in the table of values are always the same, which is kind of cool. Okay, so let's see what the rest of our graph would look like if we plotted these negative values over here. So this was -1, this was -2, continuing this way, okay, -3. Okay, so we had a point here at -1, 1. So -1, +1. And then the next point was -2, 4. So -2, 4 would be here. Then we had -3 and 9. Then we had -4 and 16. Then we had -5 and 25. And then we had -6 and 36, which would be about here. So now, hopefully this is all coming together. You can see that we have this familiar shape. It's only familiar because I've kind of given you a sneak peek over the last couple weeks. Now you can see this big parabola, okay, this one parabolic shape. So that's pretty cool. That is your basic parabola. That's y equals x squared. That's like the most important parabola that we'll talk about all year. And we're going to take that parabola and we're going to do all kinds of fancy stuff with it to turn it into other parabolas that we can use for different kinds of questions. But there you go, most basic parabola. Awesome. Okay, so we can use those experiments where we looked at parabolas to talk about what makes lines and parabolas different from each other and same. So what I'd like you to do is I'd like you to turn off this video for a second and turn and talk to each other. Look through all your notes from the other day. So take about two or 3 minutes to do this and make a list of all the things that are similar or different about lines and parabolas. So stop the video right now and do that. 2 to 3 minutes, work together, go. Okay, so welcome back. Hopefully you've talked about a few things. Number one, I'm sure the first thing that you said is that lines are straight, and you're so right about that. Lines are definitely very straight. So number one, a big difference is what the graph looks like. Lines look like that. Cool. Parabolas are different, of course. They don't look straight. They look like this, a big U. Or they might look the other way. They might be pointing down. So opening down may look something like that. Hopefully you did remember about what makes lines in a table of values. So when you have your table of values, that that whole XY thing looks something like this. So in that table of values, then you would find out that your first differences okay, so what's special about first differences with lines? Hopefully you remember that your first differences with lines are the same. Oops, that's supposed to be an S. Sorry, it's really hard to write on this computer. Okay, so first differences are all the same. And that's different from a parabola, of course, because as we saw on the last slide, with parabolas the first differences are not the same, but the second differences are 0. Okay, so that's a key feature for sure. In your table of values, then the second differences are 0. Sorry, your second differences are the same, not 0, sorry, are the same and not 0. So I know with a line, you would have found that the first differences are the same and second differences are 0. With parabolas, the second differences are the same but are not 0. So if they are 0, it's because it's a line, not a parabola. Okay, other things that you might have looked at. The straightness of the graph, the first differences being the same. Because the first differences are the same, that means that you have what we call like constant rate of growth. Or constant rate of change, I should say more generally. Constant rate of change. Okay, you might have written it that way, rate of change like this. Okay, parabolas don't have that. They have a changing rate of change. So we can see here, it doesn't go up and down by the same amount because, well, first of all, it goes down and then up. That's a totally different thing. So it's not a constant rate of change. Secondly, you can see that the parabola is steeper around the edges than it is at the top. So if I were to draw a line like showing the slope, here it's really, really steep, whereas up here it's really, really flat. So we have changing slopes, so we don't have a constant rate of change with a parabola. You might have talked about direction. So with a line, this is what a positive direction looks like, and with a line, this is what a negative direction looks like. With a parabola, we do have that idea of positive and negative, but this is what positive looks like this, and then this is what negative looks like. Cool. Okay, we'll break down a few more in just a second on the next one. Okay, so what I want you to be focusing on from here on in is talking about those key features of parabolas. Okay, so we're going to look at the equations, we're going to look at the table values, and we're going to look at the features of their graphs. Okay, so number one is trying to figure out how you can tell by looking at something whether or not it's quadratic, and that's why we just made that list a second ago. So number one is how do you tell when you're looking at the graph? Number